A very good morning to all of my dear viewers. So in today's session we are going to discuss very important topics of forensic medicines, and the name of topic is drowning. So without any delay we can start the topic with the definition of drowning. So what is the definition of drowning? Drowning is basically it is a form of asphyxia due to the entry of water into the airways and the lungs alveoli. So when there is the entry of water into the airways and the lungs alveoli, it impairs the gaseous exchanges, and when the gaseous exchange get impaired, it increase the CO2 levels and decrease the oxygen level. We call this condition as a asphyxia. So what happen in case of drownings? First, any person fall down into the water. As they fall into the water, there is entry of water into the airways and the alveoli, and this entry of water, as water enter into the airways and alveoli, it impair the gaseous exchange, and when the gaseous exchange get impaired, it increase the CO2 level and decrease the oxygen level, condition called asphyxia. So the finally death of the person will occur due to the asphyxia. So this is overall the definition of drownings. So after discussing the definition of drowning, the next topic is different types of drowning. So we broadly classify the drowning into the two types. One is the seawater drownings and another is freshwater drowning. So this seawater drownings and the freshwater drownings, it is further classified into the two types. One is the typical seawater drownings and atypical seawater drownings, and in comparison of freshwater, it will also divide into the two types: typical freshwater drownings and the atypical freshwater drowning. So overall, we can divide both seawater drownings and the freshwater drownings into the two categories. One is the typical and another is atypicals. So what is the difference between these typical and atypical drownings in case of seawater drownings and in case of freshwater drowning? So first we try to discuss the typical drowning in freshwater. So what is the meaning of a typical drowning in freshwater? So I already discussed that typical drownings means there is entry of fresh water into the airways and lungs alveoli. So when there is the entry of fresh water into the airways and the lungs alveoli, the concentration of salt in a fresh water is 0.6% and the concentration of salt in our blood circulation is 0.9%. That means the water which are enter into the lungs alveoli, they are hypotonics as compared to the blood or a plasma which present in a pulmonary capillaries. So we already know that there is always flow of fluid from their low concentration of salt to the higher concentration of the salts. So the same things here will also occur. There is movement of water from the lungs alveoli into the pulmonary capillaries, then followed by circulation. So what happens when there is the entry of water into the systemic circulation? It increases the water level in systemic circulation. We can also call it increase the circulatory capacity of body. So when there is the hemodilation will occur due to the entry of fresh water into the circulatory systems. So due to this hemodilation, when the blood volume in blood circulation will increases, it creates more overload to the heart. So the first thing is that it exert or creates excessive overload to the heart. The another things what happens in this hemodilation, or we can also say it is a hypervolemia. So due to this hypervolemia condition, there is swelling of RBC, and when there is the swelling of RBC at a maximum extent, it will burst, and when the RBC get burst, it release lots of potassium ions. So in bloods there is a hyperkalemia. Why this hyperkalemia will occur? Because due to the hemodilation, there is the swelling of RBC, and at maximum extent this RBC get burst, that release the lots of potassium ions into the circulation. So this hyperkalemia, I mean excessive potassium ions, what it will cause? It block the sodium channels in myocardial tissue. So when it block, or especially we can say that it blocks the sodium channels in a myocardial tissue or ventricular myocardial tissue. So when it blocks the sodium channels in ventricular myocardial tissue, it inhibits the depolarizations, and when the depolarization of ventricular myocardial tissue get inhibited, they also inhibits the contraction of myocardial tissue. So when the contraction of myocardial tissue get inhibited, the efficiency of contraction of myocardial tissue, especially the ventricular myocardial tissue, gets significantly reduced. And when the ventricular myocardial tissue, their contraction ability is significantly get reduced, they fail to pump the bloods. So two things will occur here. One side, due to the inhibition of sodium channels by hyperkalemia, they inhibit the strength of ventricular contraction, or we can say that they are the minimum, or they inhibit the strength of ventricular contraction at the maximum strength. So when there is one side, there is the inhibition of ventricular contraction, and another sides there is increase of afterloads due to increase the blood volumes. So due to these two things, the heart are in a state, at this condition they fail to pump the bloods, and when the heart is fail to pump the bloods, I mean there is the cessation of circulatory systems, then what happens? It causes myocardial, first it will cause the myocardial ischemia, then myocardial infarction, and finally the cardiac arrest will occur. So this is the pathology of death in case of typical freshwater drowning. So what happens in case of typical seawater drowning? In seawater, the salt concentration is higher than blood circulatory concentration. I mean, in our blood, 0.9% salt concentration. In case of seawater, there is more than 3% salt concentration. So when this seawater enter into the airways and the lungs alveoli, now the opposite things will occur as a comparison to freshwater drownings. In case of freshwater drownings, there is the movement of water from lungs alveoli into the blood circulation, so it causes hemodilation. The reverse things will occur in case of seawater drownings. In case of seawater drownings, there is a movement of plasma from blood circulation into the alveoli. So here alveoli are filled with what? Blood plasma, little bits air. But in case of freshwater drownings, mostly the lungs alveoli are filled with air, because most of the water enter into the blood circulation due to the hypotonic natures. So in case of seawater drownings, since blood are moved from blood circulation into the alveoli, there is hypovolemia. In case of freshwater, there is hypervolemia. But in case of seawater, there is hypovolemia. So whenever there is the hypovolemia occurs, the person first undergoes the circulatory shocks, and after the circulatory shock, the next steps is again a myocardial ischemia followed by myocardial anoxia, cerebral anoxia, brainstem anoxia. So these are the terminal cause of death in case of seawater drowning. So here I overall discuss the pathophysiology of seawater drownings and freshwater drowning of atypical types. Now we move towards the atypical types. Here we discuss about the typical types. Now we move towards the atypical types. So what happen in case of atypical types? In case of atypical types, as any person fall into the waters and there is entry of water into the trachea, there is a strong stimulation of laryngeal reflex. So due to the strong stimulation of this laryngeal reflex, they strongly close the vocal cords to prevent the entry of waters. So as they prevent the entry of water, along with they can also inhibit the entry of air. So here lungs alveoli are not get filled with waters. So the second thing is as the vocal cords are closed, there is no entry of oxygen or the airways, not air. So as there is no entry of air, again the same condition will develop. First develop the asphyxia, then anoxia, and finally the death of the person will occur due to the cardiac arrest. So this is overall the pathophysiology of drownings. Now we move towards the reading section. What are the things written here? So definition of drownings, it is a form of asphyxia due to the entry of water into the air passage when any person partially or completely submerged in water. Types of drowning: freshwater drowning, salt concentration is the 0.6%. Seawater drowning, salt concentration is more than 3%. Typical drowning, atypical drowning, both in case of seawater drownings and freshwater drownings. In case of typical drownings, first there is the entry of water into the airways and the alveoli that impair the gaseous exchange, which cause asphyxia. So here the underlying cause of death is the entry of water into the airways and alveoli. Intermediate cause is asphyxia, and the immediate cause of death is the ventricular fibrillation. This ventricular fibrillation means impaired ability or absence of effective ventricular contraction. This absence of effective ventricular contraction will occur due to what? Blockage of sodium channels by the potassium ions. And why this blockage will occur? Because the person in a hyperkalemic stage. So potassium ion inhibits the sodium channel, which cause the ventricular fibrillation. I mean absence of effective ventricular contraction. So when ventricular node undergoes contraction, definitely the cardiac output will be almost zero and the person will finally die. In case of typical seawater drownings, entry of water into the airways, and here the underlying cause, I mean their entry of water into the airways, this is the underlying cause. Immediate cause is the asphyxia, and the immediate cause is the myocardial anoxia, cerebral and brainstem anoxia. Okay. While in case of atypical drowning, both in case of seawater plus freshwater, as there is water try to enter into the trachea, a strong and persistent tracheal reflex will be produced which prevent the entry of water along with air into the alveoli. So here the underlying cause is the laryngeal spasm, intermediate cause is asphyxia, and the immediate cause is the cerebral and the myocardial anoxia. Okay. Now the next thing is immersion syndrome. So what happen in case of immersion syndrome? Whenever any person is fall down in cold waters, there is a strong stimulation of vagal reflexes, and this strong stimulation of vagal reflexes, they cause a severe bradycardia, and after the development of severe bradycardia, finally person undergoes cardiac arrest and death will occur. The next thing is the shallow water drownings. So in case of shallow water drownings, even a low level of water can lead to death of a person if person are unconscious when they fall into the waters. The next thing is the near drowning. If any person survives more than 24 hours, we call it as a near drowning. Secondary drownings, when death of person will occur due to the complication of drowning. So this is all over the drownings. Welcome back in next session.